Welcome to the Valve Studio for May the 29th, 2017. What I got here on the bench is an RCA Orthophonic stereo record player from about 1959. AJ found this on one of his many travels around the state of Colorado, and he started doing some mods on this to make it into a guitar amplifier. He wanted me to take a look at, where he was. He basically had taken the record player mechanism out. He's going to put a speaker in there. It's got a really big cavity there for that. So I put it on the bench here, and it's got some problems. Actually, it has some big problems. When I actually powered it up, some sparks started flying. Literally, there were sparks, and we'll go ahead and show you what that problem was. And what I'm going to end up doing with it, I can fix those problems. But it turns out that this particular record player, I think it has a ceramic cartridge. Ceramic cartridges have an output from about half a volt to 1.2 volts. So the gains are set up specifically for a ceramic cartridge. AJ likes to play Fenders, so those are single coil pickups. And those put out between about 20 and 50 millivolts. So there's quite a bit of difference in that. So if he were to just plug in his Fender into one of these, he wouldn't get very much volume out of it. So we have a little bit of a challenge to modify the circuit and increase the gain. And there's no need for him to have stereo. It does have two amplifiers in it. They're single-ended 6AQ5 amplifiers, which are probably putting out maybe 4 watts. We'll check that. But there's no need for him to have stereo. He's not going to do any kind of fancy things with it. So I'm going to modify the circuit a little bit and couple the gain stages together, the original preamp stages, and have those drive the stereo amplifiers as outputs. So let's take a look at the problems that I found. Well, first of all, let's take a look at the circuit schematic, because there are some unique things that I haven't seen before. And we'll go ahead and talk a little bit about those, and then I'll show you what I found in terms of the problems, the immediate problems, and then there's some other problems as well. So we're going to go through some of those, and then we're going to go talk about what kind of mods I'm going to make, and those mods are going to be based on some discussions that I read about in Merlin Benchlow's Benchco's designing tube preamps for guitar and bass. All right, let's get started. Here's a schematic I got over at radiomuseum.org. It's for a chassis number RS-175A, and you can kind of see it's a standard record player. Or here's the ceramic cartridge and the motor switch. Motor switch turns on the power to the transformer. Goes through a 6x4 rectifier tube. And we have a filament winding off the power transformer to run 6AU6 preamp tubes and 6AQ5 output tubes. This has 4 speakers over here, 2 for each channel. 6 1/4 or 6.5 inch and a 3.5 inch with a 4 microfarad filter capacitor or crossover cap. So what I'm going to do here is I think I need to zoom in on this. So this is going to make the camera go crazy. Get this out of the way. My lens is not very. My camera mount's kind of goofy. Okay, let's zoom back out here. All right. We're just going to concentrate on one of the amplifiers and talk a little bit about what's going on here. So here's the main input signal. Comes in from the cartridge right here and goes to a 5 meg bass tone potentiometer down to ground. So basically what this does is it connects a variable resistor from the input signal to ground. I have no idea how this actually affects the bass. What I suppose is that loading the cartridge, one of these ceramic cartridges, with additional resistance probably changes its output characteristics, and this affects the bass response. This whole thing right here is completely kind of worthless for our guitar pickup. So we'll go ahead and we'll be taking this out, which is good because this potentiometer comes through the front panel, and we can take advantage of that hole for some other things, which we'll talk about. Then it immediately goes into a 5 meg loudness potentiometer. For our guitar amplifiers, this is in the wrong location, so we're going to have to fix this. We'll replace all this over here with 68K resistor with a resistor to ground in a kind of a standard Fender input topology. And here's our first 6AQ6. And what's nice about this schematic is it's got all the DC voltages listed. So they're running it between 43 and 95 volts. This was a little bit confusing when I first started it. The screen is running between 42 and 47. There's a star here, and it says voltages. It says voltages vary with setting of balance control. So this is interesting over here. There's a balance control in this thing, and those are actually individual pots that you can change the gain, apparently, of an individual channel. So there's 2 pots here, and these are on the circuit board, but they're not brought through the front panel. And so our cathode resistor is somewhere between 560 if the wiper is all the way down here, or it's up to a little more than 2,000 ohms if the wiper's up here. This thing says a cathode varies between half a volt and 1.3. So we'll talk about the implication of this. I've never seen a gain stage like this that actually modifies the bias point. And this is also very interesting. Running the screen at this low voltage, excuse me, makes it pretty interesting to look at the data sheets, because most of the data sheets are nowhere near this low voltage. We have a capacitor across the output that we actually shunt the high frequency out through the treble tone control potentiometer, and our load resistor on the first stage is 270K. That's capacitively coupled over to the output, and we have a 6AQ5. It's running in a single Class A configuration. We have a just regular output transformer running our speakers, and this is just standard cathode biased output stage. We do have a little feedback running around here. This is a 39K resistor going from the output of the output transformer back over to the cathode of the preamp. And then there's 2 circuits coupled together here for right and left channel. This power supply down here, this thing says 252 volts at 90 milliamps. This is kind of what we got to play with. So let's talk a little bit about what we're going to do. I'm read through here and I got some tips back. This is Merlin Benco's book on designing 2 preamps for guitar and bass. This book is excellent in a discussion about doing everything I'm about to do. So what he recommends is, and this is kind of normal fare, is the pentodes used in the first stage of guitar amplifiers have a lot of potential problems with microphonics, and we will definitely be experiencing that in this enclosure, where the speaker is basically sitting right on top of the amplifier itself. And he said, you can use them here, but if you need to make the gain of the first stage less than 100, and then you need to have a subsequent stage to go ahead and give a little bit more amplification. So we can do that. And some of the early Vox AC15s took the, I think it was an EF86 pentode, and they were They had a lot of problems with microphonics with that, so they eventually just switched over to an EC83, which is a triode. We're not going to do that. I don't want to pull these sockets out of here. They're riveted in. That would be a pain in the ass. But I think what I can do is run this first one as a triode strapped pentode, and then take this output voltage right here and run it into the other channel's pentode, and then take this one's output and run both of these from this one's output. So we'll have two amplifiers running our speakers separately like it was before, but we'll have a preamp stage that's basically a triode running into a pentode. Now what Merlin says in his book is, he says that, you know, pentodes have, and there's a whole chapter written on this. He talks a lot about different configurations and flexibility that a pentode stage has for tone generation for a guitar amplifier. So we'll start looking into some of that, and this enclosure is really kind of small, but since it's here and it kind of works, I did check all this stuff. It does kind of work, not very well. We'll talk a little bit about that in a minute. But I think I'm going to run this into a particular kind of mode where you'll have a mechanism at which you can switch it between pentode and triode mode, not with a switch, with a potentiometer. He talks about that in his book. I'll show you that here in a minute. And also, we're going to run this one down here and do some tone work. Okay, so I'm over here in chapter. Well, let me zoom back out again here. I'm in chapter 2, which is this Small-Signal Pentode. He gives some summary here, and this is an interesting discussion right here. You can read a little bit about this on his site, the Valve Wizard site, where he talks about how to read the curves out of a data sheet, because he basically says data sheets will publish a curve. I'll show you one here for the 6AU6. So they will typically publish a plate characteristic like this. And up here you'll see that, no, not this one, hold on. Alright, so they will publish a plate characteristic like this, and it'll say where it's rated at. So it says EC3, which is the suppressor, is at 0. EC2 is 150 volts. Okay, this is kind of what a new tube would look like. And here are the plate curves. And then down here, these are the screen curves. He says that what do you do if you're not actually running your screen at 150 volts? Okay, so he said chances are you're not going to run at where the manufacturer has curves for. So he talks about how those curves change when you decrease the screen voltage. So here's 130, and they pretty much look like that graph I just showed you. And then here's 100, and you kind of see he did not change the y-axis on this graph. So you can kind of see that this is a 6 here. It goes up to maybe almost 8 milliamps. And then down here at 100, we ran the screen down to 100. This top curve when the grid is at 0 is now less than 6. Here's 70, it goes down to less than 4, and here is 30, and it's down less than 2. So what ends up happening is this curve here gets smashed down as you decrease the screen voltage. All right. And which brings up this next curve. These are General Electric data sheets. These are actually always have really good graphs in them. This plate characteristic here shows you at EC1 which is the grid voltage, is at 0, and the suppressor is at 0. And these curves are those there's two here. There's two curves here. So this is 150 volts right here for the screen, which effectively is the top line on this characteristic here. So if you decrease your screen, you're basically taking. Let me see if I can get this on the thing at the same time. Okay, so there's an equivalent two lines on my graphs here. This top curve on this graph is this top curve on this one. If I decrease the screen down to, like, say 100 volts, now that's going to take this top curve and scrunch it down. And so this graph here is showing you what this top curve is going to look like when you change and reduce the screen voltage down, which is exactly what he's got in the book here. So this is a really interesting graph. It kind of gets you in the ballpark of where you should look. Now, why is that important to us? Because they are running their screen. Let me get this all out of the way. They're running their screen at between 42 and 47 volts. So basically, we have this top curve, which is our bottom part of the graph, and we're taking this whole graph and basically smashing it down so that all these individual grid curves are all down in here. Now, why did they do that? It turns out that let's see, he says that increases the sensitivity of the amplifier. And that's probably what they're trying to do here. For us, we don't want that. We're just going to go ahead and couple these two stages together and make this into a guitar amplifier. All right, let's take a look at some of the problems that I found in this thing. Well, I got my camera set up. I may have to zoom in on this guy. Yeah, I just hold it up here. All right, this is one of the tube sockets. And this is the output tube for the 6AQ5. And when I turned it on, I saw some sparks. I mean, I literally saw some sparks. Some smoke came out of this thing. And, I turned it off. And I ramped it up with my Variac. And it ran for a little bit, and then pow, it's kind of a little bit scary, but that's okay. So this pin right here, this pin has got some burn marks on it, and I figured, well, maybe it's kind of dirty. So I took this out, and I used my what do you call those little brushes to clean your teeth with. I got down in here with some alcohol and kind of cleaned up these contacts, thinking, well, I'll be able to fix that. It's just a loose contact. But it wasn't. It turns out that this whole socket, I just needed to replace it. And I believe that what we were seeing in the sparking was a high voltage arc going on between these two pins. Because whatever caused this originally, there is a deterioration right here of whatever this stuff is called, a phenolic. It's deterioration right here, and there was some sparking going on between these two pins. All right, well, I have plenty of 7-pin sockets like this, but I don't have some that are this big. This spacing here is 1 1/4 inches, and typically my sockets are much smaller. So I had a mounting issue, and I will show you what I ended up doing for that, if I can find it here. Oh, here we go. All right, the first thing I did was I 3D printed this washer. And so basically these holes are These outer holes are the 1 1/4 spacing. These inner holes are my socket spacing. And you know, this, I did this in FreeCAD, and I just printed this out. This is 4 millimeters thick. And I went to put this in, and there clearly is clearance problems in the chassis. Hadn't thought of that. I thought, oh, I'll just print a big washer, basically, and with 4 holes in it, and we'll be good. All right, well, that didn't work. So the next thing I printed was one that kind of looked like it. And, you know, so here's my 2 comparisons here. And somehow I took measurements wrong, which is pretty common for me. And I got this hole way too big. So that's my second print. But you get kind of the idea. All right, so the third print, see if I can show it to you here. We may have to move my camera here. Get this thing over here. I got to disconnect a couple things. All right, so here's my third print. And my third print, I actually got the, I rotated the socket in my washer so that pin number 1 would roughly be in the same location as the old pin number 1. Where'd it go? Because I didn't want to have to completely rewire it, and they were really quite tight on their wiring length tolerances. So I rotated that, got it all together, and it works pretty well. And then now he's got a really nice socket in that one location. And then I was able to basically pull all the wires off and solder them all back in again. Okay. So here's our amplifier. I'll go ahead and show you some other things. I was going to disconnect all this, but we're doing it all in 1 or 2 takes. All right, so here's our amplifier. And so we got, well, sorry, it's upside down. The rectifier's here, which is this guy. Interesting down here, this thing says it's a 6W4, but this schematic over here says 6X4. I don't even know what's in here. It's a 6X4. Okay, so that's... All right, and then we got the right output tube and the right preamp, which is this guy's here. And here's the left channel. And then these are those balance pots that I was telling you about in the schematic. Here are the output transformers. Power transformer here, and this guy is a 4 capacitor enclosure. So it's got all 4 caps in it for the power supply. It basically has these 2 caps down here, a 30, a 15, and then the bypass caps for the output tubes right here at 25 microfarads. All right. Well, when I plugged it in, this is the tube that sparked, and then we fixed that. And then one channel worked okay. It wasn't very loud, and it certainly didn't get distorted. You pretty much have to turn the volume all the way up, and it still wasn't very distorted. After I did my fix here, I checked some voltages on the other channel, and when we started playing with it, and the voltages were way off. It turns out one of these pots is bad. I think it's open, and it doesn't have, there's no change in the gain when you tweak it. Now, unfortunately, they riveted these pots in, which I guess was pretty commonplace back then. A rivet's probably a lot cheaper than a screw. Certainly is a lot easier to put in from a manufacturing perspective. All right, so we got our work cut out for us. Well, that's the introduction to the record player mod we're going to do. Please stay tuned for additional videos when we reconfigure the preamp pentodes and some other things. We'll take some measurements here on the bench. We'll kind of check the power output, bandwidth. We'll also look at the frequency response of this record player mod. If you made it all the way through this video, thanks for watching, and stay tuned for more videos on the record player mod.